Hello students, welcome back. I am Rinkesh sir and today we'll continue with the miscellaneous exercise 5 of chapter number 5, continuity and differentiability. We'll try to complete this exercise today. We have already completed most of the exercise. So now let's start with question number 19. Question number 19. Using mathematical induction, prove that d by dx of x raised to n equal to nx raised to n minus 1 for all positive integers n. So first we'll prove for p of 1. We'll assume for p of k true, that is true, and then we will prove p of k plus 1 is true. So for p of 1, LHS d by dx of x raised to 1 and that is equal to 1. RHS 1 x raised to 1 minus 1, that means x raised to 0, that is equal to 1. Hence p of 1 is true. Okay, now let's assume p of k is true. That implies d by dx of x raised to k equal to kx raised to k minus 1. Let's name this as 1. Let's name this as 2. Now for p of k plus 1, we have to prove d by dx of x raised to k plus 1 equal to k plus 1 x raised to k plus 1 minus 1. So that will be k. Okay, let's check LHS. LHS is d by dx of x raised to k plus 1. So x raised to k plus 1, I can write it as d by dx of x raised to k into x. Okay, so now we'll use the method of UV. X as it is, d by dx of x raised to k plus x raised to k as it is, d by dx of x. So this will be equal to x. Now d by dx of x raised to k, we have taken the second equation, that will be equal to kx raised to k minus 1 plus x raised to k d by dx of x 1. So now see x into x raised to k minus 1. So k minus 1 plus 1 k. So kx raised to k plus x raised to k. So in both this x raised to k is common. Okay, so this will be k plus 1 into x raised to k and that is equal to RHS. Hence p of k plus 1 is true. Hence p of 1 is true for every n belonging to n, means for every positive number. Okay, so this was about question number 19. So just note it down. Now let's move to the next, that is question number 20. Question 20. Using the fact that sine a plus b equal to sine a cos b plus cos a sine b, and the differentiation, obtain the sum formula for cosine. Okay, let's first write down the formula. Sine a plus b equal to sine a cos b plus cos a sine b. Now you have to use differentiation and obtain the formula for cosine. So what I will do, differentiate with respect to x. So now derivative of sine is cos into d by dx of a plus b, dA by dx plus dB by dx equal to, now sine a cos b I will use uv, Sin A as it is, derivative of cos B, that is minus sin B into dv by dx plus cos B as it is, derivative of sin is cos A into dA by dx. Clear? Now for this one. Okay, cos A as it is, derivative of sin B cos B into dv by dx plus sin B as it is, derivative of cos A minus sin A dA by dx. Okay, so from now this both dv by dx is common, and from this both dA by dx is common. So what I will do, dv by dx. Okay, I'm writing this first, cos A cos B minus sin A sin B plus, now I will take dA by dx common. Now I'm writing this first, cos B cos A, so rearranging cos A cos B minus sin A sin B. Now see, cos A cos B minus sin A sin B, cos A cos B minus sin A sin B common. So what I can write it down, this cos A plus B into dA by dx plus dB by dx is equal to d. Now see, in both these I am taking common, so cos A cos B minus sin A sin B. Okay, so now here it is remaining dB by dx, here dA by dx, so dA by dx plus dB by dx, so this will get cancel. So cos A plus B is equal to cos A cos B minus sin A sin B. Okay, hence we have derived the formula for some formula for cosine by differentiating the sum formula of sine. Okay, so this was about question number 20. So just note it down. Question 22. If y equal to, it's given the determinant fx, gx, hx, lmn, and abc, then prove that dy by dx is equal to in determinant form f dash x, g dash x, h dash x, lmn, abc. Okay. So see here y is given in the form of fx, gx, hx, lmn, ABC. Now see, whenever you are differentiating the determinant, how you need to differentiate it? First, let's see if there is a determinant like E, B, C, D, E, F, G, H, I. Okay, if this is Y, then differentiating dy by dx, this will be A dash, B dash, C dash, means differentiating A, B, and C, D, E, F, G, H, I as it is, plus A, B, C. Now differentiate the second row, D, E, F, D dash, E dash, F dash, G, H, I. And third time, differentiate the third row and first two row as it is. Okay. So one by one, you have to differentiate all the rows. Clear? You can also take the column, means differentiating first column plus differentiating second column plus differentiating third column. But you cannot merge, like if you select column, then you need to differentiate column all the times. If you select a row, then you need to differentiate row. Okay, so we will use this method. Okay. So now dy by dx. First, I will differentiate the first row. So it's f dash x, g dash x, h dash x. Okay. Then second row. dl by dx. Now see, L is constant, so this will be, sorry, we don't need to differentiate the second and third row. In first case, we only need to differentiate the first row. Plus, now I will differentiate the second row, means fx, gx, hx as it is. Derivative of L, L, M and N are constant, so the second row it will be 0, 0, 0. Third row as it is. Okay. Now it's time to differentiate the third row. First row as it is. Fx, gx, hx. Second row as it is. L, M, N. Third row. A, B, C, all three are constant. So it will be 0, 0. So this will be equal to determinant of f dash x, g dash x, h dash x. L, M, N, E, B, C. Now we know that in a determinant, if all the elements of any one row or any one column is 0, then the determinant value is 0. So this will be 0 and also this will be 0. Hence, dy by dx, this will be equal to f dash x, g dash x, h dash x, L, M, N, A, B, C. Okay, hence we have proved. Clear? So this was about question number 22. So just note it down. Okay, now let's move to the next question 23. That is the last for this exercise. Question 23. If y is equal to e raised to cos inverse x minus 1 less than equal to x less than equal to 1, then show that 1 minus x square d square y by dx square minus x dy by dx minus a square y is equal to 0. Okay, so first y is equal to e raised to a cos inverse x. Now see, you can see here the term d square y by dx square. That means you need to differentiate it twice. So first differentiate with respect to x, y by dx, or I can say y1. Derivative of e raised to x is e raised to x. So e raised to a cos inverse x, e raised to a cos inverse x into d by dx of cos inverse x. Okay, so this will be e raised to a cos inverse x. Derivative of cos inverse x minus 1 upon root of 1 minus x square. Okay, so y1 is equal to e raised to a cos inverse x into minus 1 upon root of 1 minus x square. Taking on that side, y1 into root of 1 minus x square minus e raised to a cos inverse x. Now e raised to cos inverse x, that is equal to y. So y1 into root of 1 minus x square equal to minus y. Okay, clear? Sorry, there is a mistake. here it will be a. Okay, because into d by dx of a cos inverse x, a as it is, so it will be e raised to a cos inverse x, and here it will be minus ay. Okay, now squaring on both the sides. Why I am squaring? Because I am having the root of 1 minus x. So it will be complicated if we differentiate this root. So squaring on both the sides, we will remove the square root. Y1 square into 1 minus x square equal to square root of minus ay is a square y square. Okay, now let's differentiate again. Y1 square as it is. Derivative of 1 minus x square, derivative of 1 is 0. So for minus x square, minus 2x plus 1 minus x square as it is. Derivative of y1 square, 2y1 into d by dx of y1, that is y2, equal to a square as it is. Derivative of y square, 2y, okay, and into d by dx of y, y1. So minus 2xy1 square plus 1 minus x square 2y1 y2 equal to a square 2a square y1 y2. Now see, 2, 2, 2 common. Again y1 square y1 y1. So the square will get cancelled. Y1 y1. So minus x y y1, sorry, plus 1 minus x square y2 equal to a square y2. Now rearranging this, I will get 1 minus x square y2 minus x y1. I am writing the second term, first term at second. And a square y2 I am taking on this side. Minus a square y2 is equal to 0. Now let's put that y2 equal to d square y by dx square and y1 equal to dy by dx. So 1 minus x square d square y by dx minus x instead of y1 dy by dx minus a square y2 is equal to 0. Okay, hence we had proved. Okay, so remember what we did. First we differentiated with respect to x, clear, and then we tried to replace the value of y again, or we need to take the value of y again. So we got here ea raised to cos inverse x. We replace that value as y, then squaring on both the sides. In some question, first we need to square and then we need to replace the value. Okay, then we differentiated once again with respect to x. Okay, then see, in each term 2y1 is common, that we cancel out. Okay, so this type of sums, the method is common. Okay, you can write down here in step for step 1 it will be differentiating with respect to x. Step 2, after differentiating we will square on both sides. And then in step 3, we will replace the function with y. Step 4, differentiate again. And step 5, if it is necessary, take 2y1 common. Okay, so these are some steps which will be common in this type of sum. Okay, here we already replaced and then we took square. Sometime if you don't want to take square, you can directly sometime replace the value without squaring also, you can differentiate it. Clear? So this was about question number 23. So just note it down. Okay, students, so that's it for today. Thank you. Here we completed chapter number 5.